For this question, we are going to solve del z over del x and del z over del y. For del z over del x, we are differentiating equation z with respect to x. So we differentiate x squared and get 2x. We treat the other terms as constant. For example, we treat y squared as a 2, and when we differentiate 2, we got 0. Hence, the answer is just 2x. Likewise, for del z over del y, we are differentiating z with respect to y. So now we treat x squared as constant. So when we differentiate y squared and other constant terms, we get 2y. For del z over del x, we sub x equals to 1 and y equals to 1 into 2x. Since x equals to 1, we get 2 as the answer. And for del z over del y, we sub x equals to 1 and y equals to 2 into 2y. Since y equals to 2, we get 4 as the answer. For this question, we are going to solve the equation with respect to x, y, and z. For the derivative of x, we just have to take note the alphabet x and treat all the other alphabets as constant. When we differentiate x squared, we get 2x. So 2x times 3y, we get 6xy. And for the other term, we differentiate x and get 1. 1 times 2z squared equals to 2z squared. For the derivative of y, we do the same. Treat all the other alphabets as constant and differentiate y. For the first term, we differentiate y and get 1. 3x squared times 1 gives us 3x squared. Since the other term does not have y, we treat the whole term as constant. And when we differentiate constant, we get 0. For the derivative of z, since the first term does not have z, we treat the whole term as constant, and we get 0 when we differentiate it. For the second term, we differentiate z squared and we get 2z. 2x times 2z, we get 4xz. For the derivative of x, we sub x equals to 2, y equals to -1, and z equals to 1 into 6xy minus 2z squared. For the derivative of y, we sub x equals to 1, y equals to 1, and z equals to 1 into 3x squared. For the derivative of z, we sub x equals to 2, y equals to 1, z equals to -1 into 4xz. We get -14 for the derivative of x, and 3 for the derivative of y, and -8 for the derivative of z.
application of chain rule can be used for a function of two or more variables, but in this case, it'll only be used for two variables. Hence, the chain rule formula is represented by dz over dt equals to del z over del x multiplied by dx over dt plus del z over del y multiplied by dy over dt. In this example, z is equals to x cubed minus 3xy squared, where it is given that x is equals to 2 cosine t and y is equals to 2 sine t. The application of the chain rule formula will be required. We'll start by solving for the partial derivatives of the chain rule, which is del z over del x and del z over del y. For del z over del x, we differentiate the equation with respect to x, giving 3x squared minus 3y squared. By subbing x with 2 cosine t and y with 2 sine t, followed by simplifying the equation to get 12 cosine square t minus 12 sine square t. For del z over del y, the equation is differentiated with respect to y, giving negative 6xy, and followed by subbing x with 2 cosine t and y with 2 sine t. And after simplifying the equation to get negative 24 sine t cosine t. Now we solve for the remaining unknowns of the chain rule, which is dx over dt and dy over dt. By differentiating x equals to 2 cosine t with respect to t to get negative 2 sine t, and differentiating y equals to 2 sine t also with respect to t to get 2 cosine t. Now we'll sub in the differentiated values that was found earlier into the chain rule formula, and followed by simplifying it to get 24 sine cubed t minus 72 cosine square t sine t.
The volume of a circular base pyramid V cubic centimeters is given by V is equals to 1 over 3 pi r square h, where r and h are radius of the base and height of the pyramid respectively. I. Find the partial derivatives del V over del r and del V over del h. We start off with del V over del r. We differentiate r. So 2 over which is equals to 2 over 3 pi r h. Then we will follow by del V over del h, which we will differentiate h, which is equals to 1 over 3 pi r square. Part 2. Given in the question, dr over dt is equals to 0.5, dh over dt is equals to 0.3, r is equals to 4, and h is equals to 5. From part 1, we already solved del v over del r and del v over del h. So del V over del R is equals to 2 over 3 pi RH. We will sub the R and H into the equation and we will get 40 over 30 pi. Also from part 1, del V over del H is equals to 1 over 3 pi R square. We will also sub R into the equation and we get 16 over 3 pi. To find the rate of volume change, we use chain rule, which is represented by dV over dt is equals to del V over del R multiplied by dR over dt plus del V over del H multiplied by dH over dt. By subbing in the value given, dR over dt is equals to 0.5, dH over dt is equals to 0.3, and the partial derivatives found in part 1. And by further simplifying the values, we will get 124 over 15 pi.
Now let's do a quick recap of topic 2. Partial derivatives is made up of two major parts: interpreting and computing partial derivatives, and the application of chain rule for functions of two variables. Interpret and compute partial derivatives. First of all, we have learned how to apply del to a given function. Del x is an instruction to take x as a variable and everything else as constants. We must also note that del x is not the same as a normal derivative of x, which is represented by dx. Given the respective values of x and y, we can substitute them into our evaluated del x equations and present a numerical answer as the final value. Apply chain rule for functions of two variables. We have already gone through the applied chain rule formula. dz dt equals del z del x times dx dt plus del z del y times dy dt. We should take note that questions do not always ask for dz dt, but the variable z can be replaced with any other variable, for example dv dt. Last but not least, we should take note that this type of questions can also ask for answers to be expressed in exact values, for example in terms of pi. We have now come to the end of the maths video. On behalf of all my team members, we hope that you have enjoyed this video and found it educational and interesting.